Here we've got some data. Now we're not into probabilities or anything. This is just data values. So we looked at how we could calculate the mean and the standard deviation from the methods. And we are focusing that we have a sample, right? It's not the population, it's a sample. So that's especially, it's important for calculating the standard deviation, which actually, when we get the variance, the standard deviation is just the square root. So let's go ahead and poke through this one and see all the steps we'll have to go through. And of course, we've got our calculator to check everything when we're done. So I'll show you how to do that. First thing we always need is the mean. We add them all together and then divide by however many there are. So we're going to just, plus, and then there's 1, 2, 3, 4, 5. We're going to divide by 5. So this will give us our mean, x bar, not mu. Mu is for the population. So we'll just plug that in. Again, you don't have to do the arithmetic by hand. So let's clear this out. And we've got 4.2. It's 4.7. 5.4. 5.8. And then 4.9. I'm going to hit enter, and then we divide that by 5, which will give us 5, right? 25 divided by 5. So come here and just put that our mean is 5. So x bar equals 5. Now to get the standard deviation, we're going to take each of these x values and subtract the mean. 4.2 minus 5. Remember, we're going to square that. Then we're going to add together 4.7 minus 5. These will be negative, but when we square them, they become positive, so we don't just cancel everything out and get 0. 5.4 minus 5 squared plus 5.8 minus 5 squared plus 4.9 minus 5 squared. And then remember, we're going to divide all of this by however many there are. Since it's a sample, we subtract off 1 to make it more accurate. Okay. This part, we'll go ahead and enter into our calculator. We don't have to show step by step after this part. Let's go ahead and do that. Let's see. Got my numbers there. So put a big parentheses. Actually, I'll do this in 2 steps. I'll divide it by 4. I'll get the answer and then divide by 4. So I don't have to worry about fractions. Let's go with this. So we've got parentheses 4.2, subtract 5, square it, plus 4.7, second insert, so I don't have to retype it, minus 5 squared, and then we've got 5.4 plus 5.4 minus 5 squared plus 5.8 minus 5. And the last one, see how it just gets tedious. We had like 30 pieces of data to do this by hand. No way. We'll just enter it in, and we'll show you how to do that in just a moment here. But just to understand the process here, 4.9 minus 5 squared. Let's see if I get all that right. That gives us this number, and then we're wanting to divide by 4. 5 minus 1 is 4, so we're going to divide this by 4. And so there's our variance. So we'll write that down. Variance was, look at it close enough, is 0.385, 0.385. And then our sample standard deviation, we'll call that just S, is the square root of 0.385. So write that. Second square root. We'll just pull up the answer, put it in there. 0.620. They want how many decimal places? Answers, really? Only one decimal place? Round your answers to one decimal place. Okay, 0.6. It seems like they should have, well, I guess the data only has one decimal place, so 0.6. So there's our standard deviation. Circle our answers here. Standard deviation here. The mean is up here. And that's good. Now, the way we can check this is we will use this feature of our calculator. We're just going to enter it in. So I'm going to clear this out. I'm going to go to Stat. I'm going to stay at Edit because I have to give my data to it. Already got data there, so I'm going to arrow up to the title, L1. I'm going to hit Clear and Enter. Notice it cleared out my list. Now I'm going to put in all the values that they gave me up here. So I just enter 4.2, 4.7, 5.4, 5.8, and 4.9. See, this is the nice things. You can check everything. I got 1, 2, 3, 4, 5 pieces of data. Let's check them real carefully. They're all correct. I now hit the Stat button again, and I'm going to go over and do calculations on the stats. These are one variable stats is what we have. So I'm going to hit Enter. List 1 is where the data is. You can change that. Frequency is unimportant. It's all that. So notice we got X bar is 5. We calculated that. And then this S sub X, that's our standard deviation, which is 0.6 rounded to 1 decimal places. This down here is the population standard deviation. It's a little bit smaller because it was divided by 5 if that was the population. So we have a check here, and then we can come back here and we'll check our answers. Yes, 5 and 0.6. I'm going to go ahead and continue into question 23 because it relates directly to what we did here. And the part we need to understand is how to apply this empirical rule. The empirical rule predicts that approximately 95% of the unemployment rates will fall. But you just have to remember that that empirical rule says that 95% of the data is contained within plus or minus 2 standard deviations of the mean. Let's put it that way. So we have our mean, which is 5, and we're going to go plus or minus 2 times our standard deviation, which is 0.06. So it gives us 5 plus or minus 1.2. So take 5 minus 1.2. So that gives you the lower end will be, subtract 1, you get 4. So that's going to be 3.8. 5 minus 1.2. All the way to 5 plus 1.2. 5 plus 1.2 is 6.2. There's our answer to that part. Forget exactly where I've got my, see, where did I put it? Oh, I gotta click in here. There it is, 3.8 to 6.2. Okay, so remember that empirical rule. If it was 68%, then the empirical rule says it's plus or minus 1 standard deviation. So that would have been 0.6. Had it been 97, 99.7, that's 3 standard deviations, and so forth. So know that empirical rule. It's pretty basic, and again, it's not exact. It's a rounded, um, but it gives us something a little easier to remember than the exact value.